All right, let's take a look at lesson 13, multiplying complex numbers. All right, so in the first part, 13.1, we're looking at what does it mean for I to be squared. So we're going to write each expression in the form A plus BI, where A and B are real numbers. And this is a complex number. A plus BI. All right, so when we multiply, so we have 4i times 3i. You're multiplying, just like if it was 4x times 3x, you're multiplying the 4 times the 3, and then the I times the I, right? So we end up with 12i squared. Well, but what is I squared? Remember that I is the square root of -1. So I squared is the same thing as the square root of -1 squared. And remember that a square root and the square cancel each other out. They're inverse operations. So you end up with -1. So I squared is -1. So this is really -12 because I squared is -1 and -1 times 12 is -12. All right, so the next one would be 4 times -3 times I, and you can just write I squared if you want to. So then we have -12 times I squared, which is -1, so that's a positive 12. Then for the next one, we have -2 times -5, that's positive 10, times I squared, so that's going to give us -10. All right, and then number 4, -5 times 5 is -25. I times I is I squared. So we have -25 times -1, so that's positive 25. And then number 5, we're squaring this. So we really have -5 times -5, and then I times I. So we have 25 times I squared, I squared, and that's -25. All right, let's take a look at 13.2. So you are going to find the match from column A to column B, and then we're going to talk about why we know it's a match. All right, so if I have 5 times 7i, well, 5 times 7 is 35, and then there's only one I, so those two go together. We have 5i times 7i, so that's 35i squared, so that's going to be -35, because I squared is -1. 3i squared, well, I squared is -1, so that's -3. Let's see. 3i quantity squared, so you're squaring the 3, which gives us 9. You're squaring the I, which gives us -1, so 9 times -1 is -9. Let's see, 8 times I cubed. Ooh, I cubed. What is I cubed? Well, remember that I is the square root of -1, and we know that I squared is -1. We just saw that. So I cubed, that's going to be the same as I times I squared. So that's the same thing as I times -1, because remember, I squared is -1, so that's -I. So here we have 8 times -I, so that's -8I. All right, then we've got I to the 4th. So I to the 4th is the same thing as I squared times I squared, if you remember your properties of exponents or your laws of exponents. And that, so I squared is -1 times -1, so we get +1. So I to the 4th is +1, so that goes with that one. All right, -I squared, that's going to give us -1. So that also should be +1. So did I mess up here somewhere? No, I didn't. So it's not a 1-to-1. So this is also that one. And then we have -I quantity squared. So that's -I times -I, which is +I squared, which is -1. So I'm going to use orange. So the 9 did not get used. And that's okay. It didn't say that each expression in A had to have an expression in B, or each expression in B had to have an expression in A. So, all right, let's take a look at 13.3, multiplying complex numbers. Okay, so we are just, when we multiply these out, kind of like when we added and subtracted, we are treating I like a variable, even though it's not a variable, but we're gonna treat it like a variable as we do the multiplication. So just like normal multiplication with variables, we're gonna distribute, and some of you might wanna write this as 5i times -3 plus 9i, just because you might be used to the monomial being in the front. That's totally fine. You can do it either way. It doesn't matter. But we're going to distribute the 5i to the -3, so we get -15i, and then distribute it to the 9i, so we get positive 45i squared. And remember that I squared is -1, so it's really -15i plus, I'm sorry, not plus, minus 45. Well, that is not in the form A plus BI. So we just need to switch that around. So it's -45 minus 15i, and that is in the correct form. Okay? All right, let's take a look at the next one. So we're going to distribute our 8. So we get 8 times -5 is -40. 8 times 3i is 24i. Then we have I times -5, so that's -5i. And I times 3i is plus 3i squared. All right. So we can combine our 24i and our -5i. And that gives us, what, 19i? And then I squared is -1, so that's a -3. And then we're going to combine the 40 and the 3. So we have -43 plus 19i, and that is in the correct form because our real number is first and then our imaginary part is second. All right. For number 3, I recommend writing it out. It's just, I think it makes it a little bit easier. Let's zoom in here a little bit. That's awfully small. Sorry about that. All right, so we have 3 plus 2i times 3 plus 2i. I just think it makes it easier when you write it out like that to be able to see everything. Because you're not distributing the square. That is not what you're doing here. You would end up missing a middle term there. All right, so we have 3 times 3, which is 9. 3 times 2i, which is 6i. 2i times 3i, which is 6i. And 2i times 2i, which is 4i squared. All right, and then remember that we combine like terms, so we have 12i there, and then I squared gives us a -1, so -1 times 4 is -4. So we end up with 5 plus 12i. All right, now let's take a look at number 4. So we have 3 times 3, 3 times -2i. What am I doing? I said -2 and I wrote -2. It's -6i. When you multiply them, 2i times 3i is positive 6i. And then 2i times -2i is -4i squared. So we have 3, our middle terms cancel, and then I squared is -1. -1 times 4, I'm sorry, -4 is positive 4. So we get an answer of 7. Now, did I do that right? Oh, no, 3 times 3 is not 3. What am I thinking? That's a 9. You're probably sitting there thinking, what is she doing? That was supposed to be 9. You're probably thinking that all along. That's okay. So the answer is actually 13 because 3 times 3 is 9, not 3. And there you go. So that is multiplying complex numbers.